Alright, so 11.2, consider a spherical shell with inner and outer radii such that, or A and B in the problem of selecting R for points uniformly distributed within a shell. Show that the PDF is this equation, and I'll go and write this down. So assume we have some spherical shell. And it has inner radius A and outer radius B. And they want to find the probability density function of selecting a point R inside here. So, if this is real similar to before, where you find the volume of this sphere, and compare that to the volume of the entire shell. So the volume of this sphere, or this shell, this differential shell, is going to be the surface area of that shell. So 4 pi r squared times dr, right? This will be the differential volume of that shell. Everybody okay with that? The area of that shell is 4 pi r squared, and then its thickness is dr. And the entire volume of this spherical shell is going to be the volume of this sphere B minus the volume of sphere A, which is going to be 4/3 pi r cubed is the equation for a sphere, right? So this is going to be B cubed minus A cubed. So we take this ratio and you get the 4 pi r squared dr over 4 over 3 pi b cubed minus a cubed. 4 pi cancels and you get 3 r squared dr over b cubed minus a cubed dr. Is that right? So this is the PDF, probability density function. We'll just call that f of r is equal to 3r squared b cubed minus a cubed. Let me write this as saying the probability of finding something inside dr. So fr dr is equal to this. So the problem asked is show that f of r is equal to 3r squared over b cubed minus a cubed. So dividing by r squared on both sides gives you that. And the cumulative distribution function, capital F of r, is equal to the integral of f r prime dr prime from 0 to r. And we're just plugging in, doing calculus. It's, what is this, 3r squared over b cubed minus a cubed dr prime. This is r prime squared. And this is not 0, this is a, because there's no sphere, or there's no shell at radius 0. And we integrate this out and we get r prime cubed over b cubed minus a cubed evaluated from r prime equal to a and r prime equal to r. So we end up getting that r cubed minus a cubed over b cubed minus a cubed is equal to the cumulative distribution function, capital F R.
It's just the A, right?
A?
The
Yes.
the bottom.
This. A. That? Yeah, sorry. I get it right small, sorry. So this is one of your answers saying that this is one of the answers. And then we have to show that R of I is equal to A3 plus rho sub I b cubed minus a cubed, all raised to the 1/3. And to be honest, I don't remember how we did this one. It says in here to use the inverse cumulative distribution function method to generate a random sample R by setting rho I. Alright, so I'll write this down. Generate a random sample R sub I by setting rho of I equal to F R of I, and solving for R of I, you get that a cubed plus rho of I b cubed minus a cubed 1/3. This looks something familiar. This looks like this, solve for R. Let's see if it's the same thing. So, I don't remember this cumulative density function stuff as well as other stuff, but looks like we use some sort of finding some random sample by setting rho of I equal to F of R sub I. And we can generate some random value here. So this is how you get this.
Is this supposed to be a cubed?
Yeah. Thank you. Any questions more on this? Not that stuff. Any questions over